Hi everyone, we're doing this math paper today. This is 9709, paper 42, May June 2023. The time is 1 hour 15 minutes. So let's take a look at the threshold before we begin. For this paper, for paper 40, A was actually at 38. B was at 30, C was at 29, D was at 18, and E was at 13. Alright. I will be doing the other paper soon. So out of 50, A was at 38, B was at 30, C was at 24, D was at 18, E was at 13. Alright, before we begin, I'd like to talk about my Patreon. If you guys want, you can wish to support me on Patreon. It's patreon.com/CIAPaperSolved. There are 3 tiers for now. The first tier is just for support. The next one is for notes and paper solving requests. And the last one is the ultimate learning experience, where you can schedule 1 to 2 video meetings with me every month. You get your name on the credits, on screen, on every YouTube video. Priority for question paper solving requests. Also access to private videos on particular topics that I'm working on for physics, chemistry, math, and bio, as well as access to all the solved question papers that I have for math, M1, P1, P3, S1, ranging from 2002 to 2023, as well as chemistry, biology, and physics, paper 1, paper 2, paper 4, and paper 5, ranging from 2002 to 2023 onwards. That is what you get for this tier. That's not included in the second tier though, but you do get access to my chemistry and physics notes for the $5 tier. If you want all the solved question papers, that's for the $15 tier. Anyway, without further ado, let's move on, starting with question number 1. All right. Oh, by the way, although it's not written, the grade for A star should be at around 6 to 8 marks higher than this, so which is around 45. A star was at around 45, maybe 44 to 45-ish. Let's start then. A mass of particle 1.6 kg is dropped from a height of 9 meters above the horizontal ground. Speed of the particle at this instant before hitting the ground is 12. Find the work done against air resistance. Alright. So how should we do this? There are multiple ways, honestly. We have to find out the work done against resistance. We know that work done is equal to force into distance. So we can find out it was dropped, right? So this is the keyword. That means we had an initial speed of 0. So we can use v squared equals to u squared plus 2s. Final speed square is equal to 0 plus 2 into a into 9 meters. So 18a is equal to 144. So how much is that? 144 by 18 is 8. So our acceleration is 8 meter per second square. Now we know that the formula for force, resultant force, is F equals to ma. So what is the resultant force? It is weight, which is 1.6 g, minus the resistive force is equal to 1.6 a. So 1.6 into 10 minus r equals to 1.6 into 8. 1.6 into 8 and 1.6 into 10 minus answer. So R gives us a value of 3.2 newtons. So we have the air resistance acting on the ball. We can simply do this now. Work done is equal to force into distance. So the air resistance, the resistive force is 3.2, and the distance moved is 9 meters, right? So we get 3.2 times 9, which is 28.8 meters. That is our final answer. Sorry, 28.8 joules, my bad. 28.8 joules. That is method 1. There is an alternate method though, using energy. I'll show you that. Wait. So method 2 entails, basically you can find out the gain in kinetic energy of the ball, which is gain in Ke is actually half mv square, which is half into 1.6 times half into 1.6 times 12 square. Let's see how much that is. So that is 115.2 joules. Now we can find out the loss in PE, which is mgh. So that is 1.6 times 10 times the height, 144 joules. So what is the work done against resistance essentially? It is 144 minus 115.2, 28.8 joules. That is all. So these are two ways in which you could do the sum. Next one. Two particles A and B of masses 3.2 and 2.4 kg respectively lie on a smooth horizontal table. A moves towards B with the speed of v and collides with B, which is moving towards A. Okay, so essentially we have two particles A and B. They lie on a horizontal, smooth horizontal table, no friction. This is 3.2 kg. This is 2.4 kg. Now A moves towards B with the speed of v, and B is also moving towards A with the speed of 6. Now, in the collision of the two particles, the two particles come to rest. I see. So, after the collision, the net momentum will come to 0 since they come to rest. Fine, let's do it. So this has positive momentum. Particle A has positive momentum. So we can say that 3.2 times V, this is positive, plus 2.4 times minus 6, this is negative, will be equal to 0 finally. As a result, we have 3.2 V minus, how much is this? 2.4 times 6 is 14.4 equals to 0. So 3.2 V is equal to 14.4 divided by 3.2 is 4.5. So we have found out the velocity of particle A. Now what? Find the loss in kinetic energy of the system due to the collision. Okay, so the final Ke is in fact 0. So let's find out the initial K, which is essentially half mv square plus half mv square. So we end up with half into, what was the mass? 3.2 times 4.5 square plus half into 2.4 times 6 square. Okay, let's do this. 3.2 times 4.5 square times 0.5, 32.4 joules times, plus, sorry, 0.5 times 2.4 times 6 square, which is 43.2. We got a final answer of 75.6. Okay, so that is it. 75.6. All of this is essentially lost, right? This is the loss. K loss is equal to 75.6 minus 0, which is 75.6 joules. All right, let's move on. Number 3, show that this is equal to 1. Okay, the system is in equilibrium. This is the keyword. Using this info, we're going to balance things out. Okay, where tan alpha is equal to 4 by 3. So do I take the vertical component or the horizontal one? I'm exactly not sure. Tan alpha, tan is opposite by adjacent, is 4 by 3. So that one will be 4 square plus 3 square root over answer, which is 5. Interesting. Okay, let's try to do this. So if I equate them horizontally, what do we get? 15 cos alpha plus 33 cos alpha is equal to 30 cos theta plus p cos theta. This is one root. So what's the value of cos alpha from this diagram? Cos alpha is adjacent by hypotenuse 3 by 5. So let's try to do this. Or you could find out alpha like this. You know that tan alpha is 4 by 3. So alpha is equal to tan inverse 4 by 3. And then you could input cos tan inverse 4 by 3. This is the same thing. It doesn't matter. It's up to you. If you can find it, it's fine. Okay. So yeah, it's 15 plus 33. We can take cos alpha common, which is in fact 3 by 5. This is equal to 30 cos theta plus p cos theta. So what do we get? 15 plus 33 times 3 by 5, which is 28.8, is equal to 30 cos theta plus p cos theta. So this is one of them. This is our first step. Now moving on to step 2, we are going to equate them vertically, which is 15 sine alpha plus 30 sine theta. 15 sine alpha plus 30 sine theta is equal to 33 sine alpha plus p sine theta. Okay, so what is sine alpha? Sine alpha is actually equal to 4 by 5. So 15 into 4 by 5 plus 30 sine theta is equal to 33 into 4 by 5 plus p sine theta. So see what I need to bring. I need to bring 30. This is 30 plus p. I have that already. Now I need 30 minus p. That means it should be 30 minus p. So I'm going to equate it like this. 30 sine theta minus p sine theta is equal to 33 into 4 by 5, which is 26.4 minus 15 into 4 by 5, which is 12. So 26.4 minus 12 is 14.4. So 30 sine theta minus p sine theta is equal to 14.4. Now what? So clearly we're almost there. We just need to take another step, right? We can actually take this common. I think we can go for 28.8 is equal to cos theta 30 plus p, that is one. And here we can go for sine theta 30 minus p is equal to 14.4. So why don't we make sine theta the subject? So we actually end up with sine theta is equal to 14.4 divided by 30 minus p. That is one root. And using this one over here, what is the other root? We can go for cos theta is equal to 28.8 divided by 30 plus p. As you can see, we've already made it over here. Now, does this formula look familiar? Something square plus the other square is equal to 1. This is in fact sine square theta plus cos square theta is equal to 1. Okay, so we know that sine square theta plus cos square theta is equal to 1 according to our identity. Now, if we input it here, we actually end up with 14.4 divided by 30 minus p whole square plus 28.8 divided by 30 plus p whole square is equal to 1. All right, that is it. I guess that's shown. It's p plus 30, right? My bad. Same thing though. Okay. Verify that p is equal to 6 satisfies this equation and find the value of theta. Okay. So let's input p6 over here. 14.4 divided by 30 minus 6 whole square plus 28.8 divided by 6 plus 30 whole square is equal to 1. So that is 14.4 divided by 24 whole square plus 28.8 divided by 36 whole square. Let's check. 14.4 divided by 24.6 whole square plus 28.8 divided by 36, which is 0.8 whole square. So 0.8 whole square plus 0.6 whole square is in fact equal to 1. It's verified. Okay, which is 0.36 plus 0.64 is equal to 1. Next, to find the value of theta, you need to use any of these equations. So for example, I'm going to use sine theta, alright? That's fine with you guys. So we can write that sine theta equals to 14.4 divided by 24, or sine theta equals to 0.6. The result, if we do sine inverse 0.6 in degrees, I'm getting 36.9 degrees. Okay, we don't write alpha in M1, it's just theta is equal to 36.9 degrees. Hopefully that's fine with you guys. Let's move on to question number 4. How many did we have in the exam? Let me check. 7. So 4 left. Let's do this. An athlete of mass 84 kg is running along a straight road. Initially, the road is horizontal and he runs at a constant speed. The athlete produces a constant power of 60. Find the resistive force acting on the athlete. When you see constant power, you can use F is equal to P is equal to FV. Also, constant speed means that the forward force is equal to the backward force. So we can write that when you see this wording, this specific wording, the resistive force is equal to the driving force. And we know that, P is equal to FV. So F is equal to P by V. So the power is actually equal to 60 while the velocity is 3. So we end up with 20 meters per second. Is that okay? That's fine. So 20 newtons, my bad. That's the force. Now then the athlete then runs up a 150-meter section of the road, which is inclined at 0.8 degrees to the horizontal. Let's check this out. This doesn't look like 0.8 degrees, I know, just to make it easier, I've drawn it like this. The speed of the athlete at the start of this section of road is 3 meters per second, and he now produces a constant driving force of 24. The total resistive force which acts on the athlete along this section of the road has constant magnitude of 13. Use an energy method. This is really important. They've told you which method to use to find the speed of the athlete at the end of the 150-meter segment. So the speed at the start is 3 meters per second. And he produces a constant driving force of 24. And the resistive force is 13. So the athlete will actually have a component of weight acting downwards, which is mg sine theta. However, we are asked to do it in an energy method, right? So I'm not going to opt for this, but rather I'm going to go for finding out the height gained at the end of the segment. This is 150 meter and this is 0.8 degrees. So we can actually go for sine 0.8 is equal to opposite, which is the height by 150. So sine 0.8 times 150 gives you an answer of 2.09. This is the height that the athlete gains. So what's the energy conversion? Always remember that any losses are on the left hand side, any gains are on the right hand side. Also, work done by the engine or driving force is on the left hand side, work done against resistance is on the right hand side. So let's write down the equation. We also need to find out another thing, right? We want to find out the speed at the end. So what's actually happening? Are we gaining speed or losing speed? Look, the driving force is 24. Resistive force is 13. And what is the component of the weight? It is mg sine theta, which is 84 times 10 times sine 0.8. Let's try to find this out. I'm just testing something. 84 into 10 into sine 0.8. Fine. It gives me an answer of minus 0.728. So what does this force indicate? We are actually losing speed. You guys need to understand that. We are actually losing speed. That means our final velocity will be less than the initial one. So this is actually the correct equation that you should write. The loss in kinetic energy, or you could simply write change, that's fine, plus the work done by the driving force is equal to the gain in GPE plus the work done against the resistive force. So let's begin. What is the loss in KE? It's going to be half mv square minus half mv square, which is half m bigger minus smaller always. In the mark scheme, they've allowed both, but as your duty, you should do bigger minus smaller, which is 3 square minus the smaller speed that we don't know of yet. Plus, work done by the driving force is 24 times 150 meters. I just use F into D. And then the gain in P is mgh. And the work done against the resistive force is 13 times 150 meters. Now, let's input the mass. Half into 84 times 9 minus v square plus 24 times 150 is 3600 is equal to the gain in GPE, which is 84 times 10 times 2.09433 plus 13 times 150 is in fact 1950. So let's do this. If you do perform the working correctly, let me show you what answer you guys are gonna get. So 84 into 0.5, 42. So 42 into 9 minus v square is equal to 84 times 10 times 2.09433, or I can just use the exact one, sine 0.8 times 150 times 84 times 10 plus 1950 minus 3600. That gives me a value of 109.2347. Now if you do solve this, divide by 42, we get 9 minus v square is equal to 2.6008. Now what is v square going to be? 9 minus answer, which is v square is equal to 6.39917. And if you root over this, you're getting your final answer as v is equal to 2.53 meters per second. And that is your final answer. This is the exact way that you should be doing it. Just remember the technique that losses are on the left hand side, gains are on the right hand side. Work done by the driving force is always on the left hand side or by the engine, and work done against resistive forces are on the right hand side. And using the values of the forces, like the forward force is 24 and the backward forces are 13 resistive force and component of weight mg sin theta respectively. Using that, I just figured out that the backward force is actually the backward force is actually greater because I got a negative value, which means that I am going to decelerate as the athlete and my final speed is going to be less than my initial one, which is why I used half m 3 square minus final speed whole square. Although it didn't really matter in the mark scheme because they did allow it. In what sense exactly? Let me tell you. 24 times 150 minus this. Oh no, it had to be done like this. The final equation had to match like this, okay? It had to match this, or else you wouldn't be getting the final marks. Also, if you did do it in using Newton's law, you would get a maximum of 4 marks rather than 6, alright? Hopefully you guys got it. Let's move on to number 5. Find least possible value of P. Particle of mass 0.6 is placed on a rough slope. It is kept in equilibrium by a horizontal force. So since they want us to find the least, if they said greatest value of P, that means P would be driving the particle. This component of P, the one parallel to the slope, would be driving the particle upwards. So then that component would be balancing weight as well as friction. However, since they asked us to find the least possible value of P, what will our equation look like? P as well as friction. Since P is a less value, this plus the value of friction, they are balancing weight. Here, weight is greater than P, the component of P, I mean. That is why it's about to fall down. However, using the least value of P as well as friction, which is acting upwards as well, the friction is acting upwards, these two forces are keeping the particle from slipping down. So essentially, since they wanted us to find the least value, remember this, in that case, the component of P as well as friction will balance weight. But if they asked us to find the greatest value of P, it would have been friction plus weight is equal to the component of P. Why? Because then P would be so great that it would actually almost push the particle up. And yeah, friction would act downwards along with the weight to prevent it from going up. Alright, so let's try to solve this. So P has two components. One is acting into, right? And wait, let me draw the weight. This is 35 degrees. So what is the component acting down the slope? It is 35. It's in equilibrium, right? It is in equilibrium. As a result, we can say that they're equal. So I can actually write that the component of weight, which is mg sine theta, right? Mg sine theta is actually being balanced by friction plus P. We need to find that angle. So I'll show you how exactly. Basically, look, this is how we do it. Uh, this angle over here is, 90 minus 35, which is 55 degrees. And according to vertical opposite angles, this angle is also 55 degrees. So you can use that if you want. That works. Also, we could be using this since we know that this is 90, this angle is 35 degree over here, right? So why don't we just use 35 degree? That would be easier for us. And also another way, these two lines are parallel, right? So according to alternate angles, this angle is 35 degrees over here. Okay, that's another way. Anyway, yeah, P, this component of P is acting up, so we can write P cos 35 degrees. This component of P that is acting along the slope upwards, along with friction, is balancing mg sin theta. So that's zero point 0.6 times 10 times sine 35 is equal to mu r plus P cos 35. So what about r? R always acts perpendicular to the slope, right? R always acts perpendicular to the slope. So how are we gonna deal with this? If we resolve it the other way, we know that R is acting up and the component of P and weight, those are actually acting downwards. So can we write this, that the component of weight that is acting downwards, perpendicular to the slope basically, which is this one, mg cos theta. So mg cos 35 degree plus the component of P, which is P sine 35 degree. This is actually equal to R, because R is acting upwards, perpendicular to the slope. As a result, we actually end up with R is equal to 0.6 times 10, 0.6 G cos 35 plus P sine 35. Or more simply, R is equal to 6 cos 35 plus P sine 35. We have R now. I should have done this first actually chronologically, then it would have made the math easier. Yeah. Now it's going to be really simple now. We just input the values, alright? So what do we do now? We can write 6 sine 35 is equal to, what's the value of mu? It is 0.4. 0.4 times 6 cos 35 plus P sine 35 plus P cos 35. Let's do this. So 6 sine 35 is equal to 0.4 times 6 is 2.4. 2.4 cos 35 plus 0.4 P sine 35 plus P cos 35. So after simplification, we end up with 6 sine 35 minus 2.4 cos 35, which is 1.4755 is equal to, if you take P common, it is actually 0.4 sine 35 plus cos 35. Okay, so what is the final answer? P is equal to 1.4755 divided by this 0.4 sine 35 plus cos 35, which is 1.04858. All right. So I'm getting a final value of P is equal to 1.41 to 3 significant figures. I used my stored calculator values, if you guys were wondering. Please try to use exact values in math. P1, S1, M1, and P3, or else it might not match. All right, let's move on to the next one. Motion in a straight line. A particle P starts at rest and moves in a straight line from a point O. At time t seconds after leaving O, the velocity of P is given by V is equal to Bt plus Ct to the power 3 by 2, where B and C are constants. P has velocity 8 when t is equal to 4 and has velocity 13.5 meters per second when t equals to 9. Show that B equals to 3 and C equals to minus 0.5. Okay, let's do this. P has velocity 8 when t is equal to 4. Alright, so velocity is 8 when t is equal to 4. So 4b plus um, c into 4 to the power 3 by 2. So what is 4 to the power 3 by 2? It is actually 8. So 8 is equal to 4b plus 8c. Or 2 is equal to b plus 2c. That is one equation. The other one is 13.5, yeah? 13.5 when it is 9b plus c into 9 to the power 3 by 2, which is 27. So 13.5 is equal to 9b plus 27c. So b is equal to 2 minus 2c. As a result, when we substitute, it is 13.5 is equal to 18 minus 18c plus 27c, which is 13.5 minus 18 minus 4.5 is equal to minus 18 plus 27, 9c. So minus 4.5 by 9 is in fact minus 0.5. And on the other hand, we know that b is 2 minus 2 into minus 0.5, which is 2 minus 2 into minus 0.5, 3. So that's shown. The other way was you could simply just, put in 3 over here and put in minus 0.5 in both equations to check, and it would match. You need to put it in both of them and show that it matches, the left and right side, I mean. For example, you could do it this way. 8 is equal to 4 times 3 plus, minus 0.5 into 4 to the power 3 by 2, which is 8 is equal to 12 minus 0.5 into 8. 8 is equal to 12 minus 4, which is in fact 8. And you would do it 2 times and show the final answer, okay? Find the acceleration of p when t is equal to 1. Okay, so by now we know that v is equal to 3t, v is equal to 3t minus 0.5 t to the power 3 by 2, and we also know that velocity, if differentiated, results in acceleration. So a is equal to 3 minus 0.5 into 3 by 2 to the power into t to the power 3 by 2 minus 1 is half. So we actually end up with a is equal to 3 minus 3 by 4 t to the power half. All right. Find the acceleration when t is equal to 1. So when t is equal to 1, it is going to be equal to 3 minus 3 by 4 into 1 to the power half. So we end up with 3 minus 3 by 4, which is 9 by 4, or 2.25. That's up to you guys. You can write anything you want. So yeah, a is in fact dv by dt. This is the thing that you need to know. Find the positive value of t when p is at instantaneous rest, and find the distance of p from O at this instant. Okay, so for instantaneous rest, v needs to be 0, right? So we can write that 3t minus 0.5 t to the power 3 by 2 is equal to 0. So we can actually take t common, and we'd end up with 3 minus 0.5 t to the power. If you take 1 common from 3 by 2, you end up with half is equal to 0. So one of them is 0, but we need a positive value, so this is not applicable. So 3 minus 0.5 t to the power half is 0, or 3 is equal to 0.5 t to the power half. So 3 by 0.5, which is 6, t to the power half is 6, or t is equal to 6 square, which is 36. That is my positive value over here. Now we need to find the distance from O at this instant, right? So we know that S is in fact the integral of V. So let's integrate. And I'm going to input the limits immediately, because I don't want the total distance traveled. I simply want the distance of P from O at this instant. The limits will be 36 and 0. So the integration is 3t minus 0.5 t to the power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 itself. And I'm just going to input the limits, which is 36.0. Then s is equal to, after simplification, wait, I made a mistake. Sorry, it's 3t over here, right? So, wait, let me do it again. So s is actually equal to, using this, right? That's the equation for velocity. 3t squared by 2 and minus 0.5 t to the power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 itself, and the limits are 36.0. So after simplification, we actually end up with s is equal to 3 by 2 t square. 0.5 divided by 5 by 2 is 1 by 5 minus 1 by 5 t to the power 5 by 2, 36.0. So let's find it out. 3 by 2 into 36 square minus 1 by 5 into 36 to the power 5 by 2 minus 0. All of them will turn into 0, right? So 3 by 2 into 36 square minus 1 by 5 into 36 to the power 5 by 2, which gives us a value of 388.8 meters exactly. Okay, this is the only answer. Now find the speed of p at the instant it returns to O. So where is O? The point where we started from. As a result, that is the point where our displacement is actually 0. So using the equation for displacement, we need to find out the time at which we return to our original point. So the equation for displacement was actually this 3 by 2 t square minus 1 by 5 t to the power 5 by 2 plus c. However, c is a constant. Let's use another letter k because c was used. So at time 0, displacement was 0. So 0 is equal to 0 plus k. So in fact, k is 0. So the final equation for displacement is 3 by 2 t square minus 1 by 5 t to the power 5 by 2. Now, we want to know the time where s is equal to 0. So 0 is equal to 3 by 2 t square minus 1 by 5 t to the power 5 by 2. We can take t square common. We end up with 3 by 2 minus 1 by 5 t to the power 5 by 2 minus 2 is half is equal to 0. So one of them is t is equal to 0, while the other one is 3 by 2 is equal to 1 by 5 t to the power half, or that is 3 into 5 by 2 t to the power half is equal to 7.5. Whole squared is t is equal to 56.25. Now we want to find out the velocity, right? So velocity's formula is 3t, excuse me, 3t minus 0.5 t to the power 3 by 2. So what is it? 3 into 56.25 minus 0.5 into 56.25 to the power 3 by 2. You are going to get an answer of do they want the speed? Yeah. So I'm getting value of minus 42.2. However, this is the velocity. Since they specifically want the speed, you have to mention at the end that speed is equal to 42.2 meters per second. Okay, they wrote in the mark scheme that if you write minus 42.2, you're not going to get a mark. Okay, so just keep that in mind. Okay, I'll check again though. 3 into 56.25 minus 0.5 into 56.25 to the power 3 by 2. Yeah, the velocity is negative, which means we're moving backwards. But since they wanted the speed, we particularly needed to mention plus 42.2. Yeah, okay. Off we go to the last question of the day. It's question number 7. It has 4, 9, 13 marks. Okay, let's end this. Two particles, P and Q, of masses 2 kg and 0.25 kg respectively, are connected by a light, inextensible string that passes over a fixed smooth pulley. Particle P is on an inclined plane at an angle of 30 degrees to the horizontal. Particle Q hangs below the pulley. 3 points A, B, and C line on the line of greatest slope of the plane with AB is equal to 0.8 and BC equals to 1.2 meters. Particle P is released from rest. Okay. With the string taut and slides down the plane during the motion of P from A to C. Q does not reach the pulley, and the part of the plane from A to B is rough with coefficient of friction 0.3, and the part of the plane from B to C is smooth. Find the acceleration of P between A and B. Fine. We know that tension is acting upwards for Q, and for P tension is also acting away from the particle, and we can use the equation F is equal to ma. Now this section A to B has friction, and we know that for P the weight is acting down the slope, and the value of friction is going to be mu r, where r is actually equal to mg cos theta. So let's find out the frictional force first. That's the coefficient, it's 0.3. So 0.3 times, mg cos 30, which is 0.3 times 2g cos 30, or 2 into 10 into 0.3 is 6. 6 cos 30, that's the friction. Now we can write for P, since it's going down, the component of weight, which is mg sine 30, is down, while tension and friction are upwards, is equal to ma. So if you equate this, we basically end up with 20 or 2g. Okay, let's do it like the Marx scheme. 2g sine 30 minus tension minus the friction, which is 6 cos 30 is equal to, I've shown it on the right hand side, is equal to 2a, or 20 sine 30 minus tension minus 6 cos 30 is equal to 2a. On the other hand, for P, it is a vertical particle, so tension is just pulling it down, up, and mg is just pulling it down, is equal to ma. The mass is in fact 0.25 only, so we can write that tension minus 0.25 g is equal to 0.25 a. Now we can equate the we can solve them simultaneously. 20 sine 30 minus tension minus 6 cos 30 is equal to 2a. This is plus t and minus t, we can get rid of them. We ultimately end up with 20 sine 30 minus 2.5 minus 6 cos 30 is equal to 2.25a. Let's find out a. 20 sine 30, which is 10 minus 2.5 minus 6 cos 30 divided by 2.25 gives me an answer of a is equal to 1.02 meters per second square. That is my answer. If we want the exact one, it is 10 minus 4 root 3 divided by 3. That is the exact answer of acceleration. Okay, but this is fine since it's irrational. It's okay. That's alright. Hence, find the speed of P at C. Okay. So, after it reaches B, it's going to accelerate without the friction, basically. So, let's find out the velocity at B right now. Let's find out the velocity at B. Velocity at B. So you can use time, or we can just simply use v square is equal to u square plus 2s. So v square is equal to 0 plus 2 into this value over here, 1.02 times s. What's the distance moved? 0.8 meters. So let's get it. So v square is actually 1.64 meters per second square, and v, if you root our answer, we could just use that simply. V is equal to 1.28 meters per second. That's fine though. Now we need to find the new acceleration again, from B to C. Okay, acceleration from B to C. Let's do that. Acceleration from B to C. Now there is no friction. Same equation without the friction, basically. Okay, same equations without the friction. So that is 20 sine theta sine 30 minus t is equal to 2a. This is one, while the other is, the same. T minus 0.25 g is equal to 0.25a. T minus 0.25 g is equal to 0.25a. We can get rid of t's and we end up with 10 minus 2.5 is equal to 2.25a. So a is actually 7.5 by 2.25, which is 3.33. Now we need to find out the velocity at c. What is the distance? 1.2 meters. So we can opt for v square is equal to u square plus 2s again. So v square is equal to u square plus 2s. Now our initial speed will be this one basically, whole squared. Right? So v square is equal to, let's find that out, the exact one. If we don't use the exact one, the answer won't match. 10 minus 4 root 3 by 3 times 0.8 times 2. So the value of the, so here it's like the velocity, the final velocity of the first phase is the initial velocity of the second stage, right? So 1.64 whole square, or 80 minus 32 root, sorry, it's just 1.64, that's the whole squared value, or just 80 minus 32 root 3 divided by 15, that's u square, plus 2 into 3.33 times 1.2 meters. That is the distance we traveled at the end to C. Let's find out the final velocity or the speed. We end up with 9.64 if I use my exact answers. So 9.64 is my final answer here, but this is the squared value, my bad. So we just have to root over the answer and we are getting 3.10 meter per second as our final answer. Yeah, so that is all for this part. Moving on to the last one. Find the time taken for P to travel from A to C completely, the whole journey essentially from A to C. Fine. So multiple ways we could do this. Also, this could be done in multiple ways as well, using an energy method, but this is fine, I guess. I think that this is the fastest route. Yeah, so let's do the last one. Time taken. So we can just use v is equal to u plus at. Okay, so v is equal to u plus at. This is the first phase from A to B. So the final velocity was this 1.28. Let me find it again. I need the exact one. 10 minus 4 root 3 by 3 times 0.8 times 2. Then root over answer. So it's 1.27995766 is equal to 0 plus 10 minus 4 root 3 by 3, 10 minus 4 root 3 by 3 times time. Okay, so this answer divided by 10 minus 4 root 3 by 3. So T1, the first phase time is 1.2500 seconds. Okay, 1.25 seconds. Next, the second phase from B to C. We can go for V is equal to U plus AT again. Now, the final velocity is actually a bit more complicated. It is, wait, 80 minus 32 root 3 divided by 15 plus 2 into 3.3333 times 1.2 root over answer. So the exact answer is around 3.104559681 is equal to 1.27995766 plus, what is the acceleration over here? It's 3.3333 times time. So let's do this. Minus 1.27995766 divided by 3.33333. So T2 is actually 0.54738. So if we add them up, total time is T1 plus T2, which is 1.25 added up. So I'm getting an answer of 1.79738. So rounded off to 3SF, that should be 1.80 seconds rounded off to 3SF. Okay. Anyway, guys, that's been it for today. I hope this helped you guys. Please do comment below if you have any questions. A quick shout out to my patrons, my $15 patrons. It's Pearl, Sean, Luna, and Dewa. So if you guys do want a shout out, please do consider supporting me on Patreon on the highest tier, and you get access to notes, solved question papers, as well as video meetings. I'll put a link in the description. And yeah, do like the video and subscribe to the channel if it helps you. It would help me a lot and support the algorithm. Anyway, I'm going to put a link for the playlist for mechanics over here. And I'm going to link the paper for May-June 2023, paper 4.1, and May-June 2023, paper 4.3 when I solve those. See you guys.